EPLANT-Piping Basic tutorial. This video shows the basic format of piping specifications and how this information interacts with the dimensional catalog. To start, we open the piping specification class, in our case the A1. EPLANT stores piping specifications in a DBF format file. We can load this file in the database module directly or importing it from an Excel file. In the first column we find the class name, here the component code. In these two columns the main diameter range is defined. In case of reductions, a secondary diameter range must be defined also. The other columns are for specifying parameters that are associated to that component in that diameter range, such as rating, schedule, main end code, secondary end code, material code, and other parameters. Let's look in detail to the component code, the material code, and end codes. Closing this table, let's see the specific use of these codes. We'll begin by looking to the component codes. Each EPLANT piping component is built from a code defined in this table. Currently, more than 300 codes are defined, but the user can add all that should be needed. Each code has a generic description associated to it, as well as several more parameters that define the behavior of that component. Let's go to the material codes now. This column defines the material code. In this one, the associated description that is used in reports to identify the material. In this one, the specific weight that is used to automatically calculate the component weight when the corresponding table is not defined. Let's look now to the third code shown in the specification, the end code. This column defines the end code. Here is its generic description, and the other column defines the behavior of each particular end code with respect to the generation of implicit elements, that is, elements without a graphic representation in a 3D models, but that are automatically generated in each connection. For example, RF is defined as a flange joint, which generates a gasket. It generates bolts also, but it does not generate a welding. Neither a clamp, and it is compatible for a connection with another RF end code. Let's see now the relation between specification and dimensional catalog. We open the project setup in the section where the default dimensional standard is defined. This standard is simply the name of a folder where the dimensional tables of each component of that specific standard are stored. Unless the class explicitly specifies the standard for a given component, dimensional tables will be searched for in the default standard folder. Here we can see the EPLANT installation and the folders corresponding to different standards. Each one of these files contains one dimensional parameter of a given component. The name of each table begins with the component code, followed by the parameter number stored in that table, and next the end code. We are going to open the table that contains the face-to-face dimensions of a flange gate valve. For example, the distance between faces for 6 inches and rating 150 is 266.7 mm. The dependence from the rating is established simply by including the corresponding column in the table. The rating value is automatically derived from the specifications during the component placement. We'll open now a table where the dimensions are function of the diameter only. For example, the radius of a butt-welded elbow depends from the diameter only. These tables can be loaded in these editing windows or importing them from Excel files. For more information, look at the advanced tutorial.